Check your understanding 8.7. How high above the bottom of its arc is the particle in the simple pendulum above when its speed is 0.81 meter per second? So based on the given problem, our velocity is equals to 0.81 meter per second. So also based on the previous problem, just like the previous problem, we neglect our air resistance in the problem and no work is done by the string tension, which is perpendicular to the arc of the motion. Therefore, the mechanical energy of the system is conserved by equation 8.13. So in this problem, we're going to use also the equation 8.13, which is the 0 is equals to change of kinetic energy plus the potential energy. Because the particle starts from rest, the increase in the kinetic energy is just kinetic energy at the lowest point. So but in this problem, we're trying to find is the height, or how high above the bottom of its arc is the particle in the simple pendulum above when its speed is 0.81 meter per second. So again, the solution. So from 0 is equals to the change of kinetic energy plus the potential energy, we arrive in this formula. Ki plus ui is equals to kf plus uf. So just like in the previous problem, our ki is 0, and we know that the potential energy is equals to mgh. So we put mgh, gi-substitute lang nato na siya, equals to of course our kinetic energy, alam naman natin na 1/2 mv squared. So and our final potential energy is also 0. So by manipulating this formula, we arrive here in height is equals to 1/2 v squared over g, or the gravity. So by substitution the value, so height is equals to 1/2 times 0.81 meter per second squared over 9.81 meter per second squared. So the height is equals to 0.033 meter. Example 8.8. Air resistance on a falling object. A helicopter is hovering at an altitude of 1 km when from its underside break loose and plummets to the ground. The mass of panel is 15 kg and it hits the ground with a speed of 45 meter per second. How much mechanical energy was dissipated by air resistance during panel descent? So based on the given problem, or given, which is are the mass, which is 15 kilogram, velocity of 45 meter per second, and the yi, or the height, is equals to 1 km. So in this problem, we only investigated one body, and the gravitational force and the air resistance is also present. So gravitational force is conservative. However, the non-conservative force of air resistance does negative work on the falling panel. So we can use the conservation of mechanical energy in the form to express by equation 8.12. So to find the energy dissipated. So in this problem, we're going to use the equation 8.12. So and we're trying to find the energy dissipated. So energy dissipated is equals to the absolute value of the non-conservative work is equals to the absolute value of the change to kinetic energy plus the potential energy. So we arrive in this formula. Energy dissipated is equals to absolute value of kf minus ki plus uf minus ui. So we all know that the kinetic energy is equals to 1/2 mv squared, and our potential energy is equals to mgh. So our initial kinetic energy and the final potential energy is equals to 0. So by the substitution, the value, so 1/2 is equals to mass, which is 15 kg, and the velocity is 45 meter per second squared. So minus 0 plus 0 minus, again, the value of mass, gravity, and height, which is 15 kg and 9.81 meter per second squared, and the value of the height is 1 km. So we convert it into meters, so it become 1000 meter. So the answer will be and we arrive in this, so absolute value of 15,187.5 plus negative 147,000. So the answer is equals to absolute value of negative 131,812.5 joule. So using the scientific notation, the answer is equals to 130 times 10 raised to 3. So our energy dissipated is equals to 100 kilojoule. So kung napansin nyo, nawala yung negative since ay tungod na sa absolute value. So bisag negative ang air resistance does negative work on the falling panel. Example 9.1, the Arizona Meteor Crater. So based on the given problem, or given are the initial velocity, which is equals to 1.28 times 10 raised to 4 meter per second, and the radius of the meteor, which is 25 meter, and its density is equals to 7,970 kilogram over meter cube. So this given can help us to solve the average force. So in this problem, we're going to find the average force and the maximum force. So let's solve first the average force. So the average force during the impact is related to the impulse by average force equals to impulse over time. So we all know that from equation 9.6, the impulse is equals to mass times the change of velocity. So now we have average force equals to m times the change of velocity over time. So the mass is equals to the product of the meteor's density and its volume. So again, the mass is equals to density and its volume, and based on the given problem, the density of the meteor is equals to 7,970 kilogram over meter cube, and the volume of the meteor, let's assume that the meteor was roughly spherical, so the volume is equals to 4 over 3 pi r cube. Now we obtain this formula. So average force equals to density times the volume times the change of velocity over time. So density, and then times the value of the volume of the meteor, which is 4 over 3 pi r cube, times the final velocity minus the initial velocity over time. Now let's substitute the value. So average force is equals to the value of the density is equals to 7,970 kilogram over m cube times the volume, which is 4 over 3 pi, radius, which is 25 meters cube, times the final velocity, which is 0 meter per second, minus negative 1.28 times 10 raised to 4 meter per second. So why negative 1.28? It's because the meteor is traveling vertically downward prior to the impact. So in that case, its initial velocity would become negative. So now the answer, our average force is equals to positive 3.33 times 10 raised to 12 Newton. So now let's calculate for the maximum force. So the impulse is related to the force function by the integral of the maximum time and the initial time. So force function dt. So we need to make a reasonable choice for the force as a function of time. We define time is equals to 0 to be moment the meteor first touches the ground. So then we assume the force is maximum at impact and rapidly drops to 0. So the function that does this is the force function is equals to the maximum force e raised to negative t squared I 2, and the parameter that represents how rapidly the force decreases to 0 squared. So the average force is equals to 1 over time, the integral of maximum time and 0. So the maximum force e raised to negative t squared I 2, and the parameter that represents how rapidly the force decreases to 0 squared dt. So where the time is equals to maximum time minus 0 seconds. So the final average, I mean, so the maximum, so the final average is equals to 0.458 maximum force. So by manipulating, which is we're going to divide both sides by 0.458. So maximum force is equals to 3.33 times 10 raised to 12 Newton over 0.458. So our maximum force is equals to 7.27 times 10 raised to 12 Newton. 9.3 Moving Enterprise. Mr. Sulu take us out ahead 1/4 impulse. With command Captain Kirk of the Starship Enterprise as his ship start from rest to final speed of final velocity is equals to 1/4 times 3.0 times 10 raised to 8 meter per second. Assuming this maneuver is completed in 60 seconds, what average force did the impulse engines apply to a ship? So based on the given problem, the given are the final velocity is equals to 1/4 times 3.0 times 10 raised to 8 meter per second squared, and the initial velocity is equals to 0 meter per second since it starts from rest, and our time is equals to 60 seconds, and the mass of the Enterprise based on research is equals to 2 times 10 raised to 9 kilogram. So what are we trying to find is the average force. So solution, we're going to use the impulse momentum theorem, which is the impulse is equals to delta p. And we all know that the impulse is equals to the mass times the change in velocity. So and delta p is equals to impulse. So equating this expression, it gives us this formula. So the force times the time times the I is equals to mass times the change of velocity. So in order to solve for the force, so we're going to manipulate this formula. So we're going to divide both sides by time. So and we are going to arrive in this formula. So force is equals to mass times the change in velocity over time. So by substitution, so let's substitute the value. Again, the mass is equals to 2 times 10 raised to 9 kilogram times the change in velocity. So we all know that the initial velocity is 0 meter per second. So 1/4 times 3.0 times 10 raised to 8 meter per second is equals to 7.5 times 10 raised to 7 meter per second over 60 seconds. So the force did the impulse engines applied to ship is equals to 2.5 times 10 raised to 15 Newton.